It just passed the sun on October 29th, last week. And after that, it changed course. And I calculated that it must have lost at least a tenth of its mass if it's a natural comet. However, yesterday there were images of it that didn't show any cometary tail.
Right.
We should at least see the mass that it lost, which is a substantial fraction of its initial mass. And we haven't yet been able to verify if that's the case. Of course, the alternative is that there is some engine that is propelling it. It's not the evaporation, the cometary evaporation of volatiles from the surface of the object. And as time goes on in the coming weeks, it's coming out away from the sun. When it was closest to the sun, we couldn't look at it because the Earth was on the opposite side. But in the coming weeks leading to December 19th, that's when it will be closest to Earth. We should learn much more about it.
Just recently, something happened to 3I Atlas that NASA didn't predict. When this interstellar object entered our solar system in July, it was traveling at 130,000 miles per hour. Fast, but expected. Textbook gravitational physics. Then it passed behind the sun. For 3 weeks, Earth-based telescopes couldn't see it, hidden from view during the most critical moment of its journey. When it emerged, 152,000 miles per hour. That's a 22,000 mile per hour increase. And before you say the sun's gravity accelerated it, no. Gravity accelerates objects as they approach the sun, then slows them down as they leave. This thing sped up after perihelion. Over the past week, that 22,000 mile per hour velocity change has pushed 3I Atlas roughly 6 million kilometers away from where NASA's original calculations said it would be. 6 million kilometers. NASA has updated its trajectory data 3 times in 7 days, trying to keep up with where this thing actually is. Did 3I Atlas just perform a controlled maneuver while we weren't looking? The velocity problem. Let's start with what we know for certain, the actual numbers they don't want to explain. When 3I Atlas was discovered July 1st, astronomers calculated its velocity, 130,000 miles per hour. That's about 210,000 kilometers per hour if you're keeping track. Incredibly fast, but not unusual for an interstellar object entering a solar system. Post-perihelion observations, released by amateur astronomers and international observatories, not NASA, show it's now at 152,000 miles per hour. That's a gain of 22,000 miles per hour. NASA's response? Non-gravitational acceleration from outgassing. The sun heated the comet, ice turned to gas jets acted like rocket thrusters. Standard comet behavior. Except, there are problems. Actually, several problems. First, objects don't gain more speed after passing the closest point to the sun. That's not how orbital mechanics works. Conservation of energy says you accelerate on the way in, decelerate on the way out, unless something else is providing thrust. Second, outgassing strong enough to add 22,000 miles per hour to a 33 billion ton object requires massive ejected material. We're talking billions of tons of gas and dust spraying into space, creating a huge visible tail pointing away from the sun. But when amateur astronomers photographed 3I Atlas on November 5th, images that are publicly available, by the way, there's no tail, just a fuzzy ball of light. Compare that to Comet Lemon, photographed by the same telescope 2 days earlier. Lemon has a beautiful, clear cometary tail, the kind you expect when gas and dust are being expelled. 3I Atlas? Nothing. So you're telling me it accelerated by 22,000 miles per hour, but there's no visible evidence of the mass ejection required to cause that acceleration? The physics don't match the observations. And when the physics don't match, someone either lying or they don't understand what they're looking at. The 6 million kilometer deviation. Here's why this matters. It's not just about velocity, it's about where this thing actually is versus where NASA said it would be. Here's the math, and I want you to follow along because this is critical. 22,000 miles per hour equals roughly 35,400 kilometers per hour. That's the speed difference between NASA's prediction and what we're observing. If an object is traveling 35,400 kilometers per hour faster than your model predicted, then every single hour that passes, it gets further away from where you thought it would be. Over one day, 24 hours, that's an extra 850,000 kilometers of travel. Over a week, roughly 6 million kilometers of cumulative positional offset from the original trajectory. 6 million kilometers. For context, that's about 16 times the distance from Earth to the Moon. That's not a rounding error. That's not measurement uncertainty, that's a massive deviation. And we know this is real because NASA has updated 3I Atlas's trajectory data 3 separate times between October 29th and November 5th, 3 updates in 7 days, each one revising where they thought it was, where it's going, and how fast it's moving. The Minor Planet Center published updated orbital elements, NASA's Jet Propulsion Laboratory released new trajectory calculations. Both organizations essentially admitted our models were wrong. We didn't predict this correctly. Now, here's where it gets interesting. The non-gravitational acceleration has been measured at a statistical confidence level of 3.7 sigma. In physics terms, that's 99.99% certainty. That's the same confidence level used to confirm new particle discoveries at the Large Hadron Collider. So NASA is 99.99% certain this object is accelerating in ways that gravity alone cannot explain. They're certain enough to publish it in official databases. But when Congresswoman Anna Paulina Luna demanded answers and data transparency, NASA's response was essentially, we'll release more information when the government shutdown ends. The government shutdown. That's the excuse for why we can't see high-resolution images taken by the Mars Reconnaissance Orbiter on October 2nd, over a month ago? Images that are already processed, already sitting on a server somewhere, already analyzed. China released their Mars Orbiter images days ago, the European Space Agency released theirs, but NASA? Sorry, government shutdown, bureaucratic reasons. You can track packages on Amazon during a shutdown. You can check weather forecasts during a shutdown. But apparently, you can't release photos of an interstellar object showing unexplained acceleration. Does that sound like transparent science to you? The blackout period. Here's what makes this whole situation even more suspicious: the timing. 3I Atlas reached perihelion, its closest point to the sun, on October 29th. But here's what most people don't realize. It had been behind the sun from Earth's perspective since October 21st. That's 8 days before perihelion. From October 21st to November 9th, a total of 19 days, this object was in Earth's solar blind spot. We had some spacecraft observations from Mars orbiters and solar satellites, but Earth-based telescopes? Nothing. It was crossing the sky with the sun during the day, completely unobservable. And that's exactly when everything changed. The velocity increase happened during the blackout. The trajectory deviations detected after the blackout. The brightening by a factor of 5 occurred during the blackout. It's like someone knew when we weren't watching. Now, I'm not saying that's what happened. I'm saying the timing is, let's call it statistically interesting, because here's another fun fact. Harvard astrophysicist Avi Loeb calculated that the probability of 3I Atlas's trajectory, bringing it close to Mars, Venus, and Jupiter, while hiding from Earth during its perihelion, is 0.005%. That's a 1 in 20,000 chance. 1 in 20,000. Jackpot, isn't it? What they're not telling us. Here's what we know NASA knows, but won't say publicly. First, they've confirmed to Congress, specifically to Representative Luna, that 3I Atlas is displaying an abnormal tail. Loeb published his analysis showing there's no visible tail despite the acceleration data requiring one. Luna tweeted that NASA admitted Loeb was correct. So NASA privately admits the tail is abnormal, but publicly they're still calling it just a comet. Second, they've calculated that the object should have lost over 13% of its mass during perihelion. That's not speculation. That's based on the momentum required to produce the observed acceleration. 13% of 33 billion tons is roughly 4.3 billion tons of ejected material. Where is it? Where's the 4.3 billion ton debris cloud? Loeb said it would be impossible to miss in observations, yet the November 5th images show nothing, just a compact fuzzy ball. And fourth, NASA acting administrator Sean Duffy responded to Kim Kardashian's tweet about 3I Atlas saying, no aliens, no threat to life here on Earth. But multiple sources confirmed that NASA hasn't briefed Congress. Kim Kardashian got a public response within hours, congressional oversight committees still waiting. What does that tell you about priorities? About what information is being shared with the public versus what's being discussed behind closed doors? So here's where we are. An interstellar object entered our solar system at 130,000 miles per hour. It followed a trajectory with a 1 in 20,000 probability, perfectly positioned to observe multiple planets while hiding from Earth during its most critical moment. While behind the sun, during those 19 days when we couldn't watch, it somehow gained 22,000 miles per hour, a velocity increase that has caused a cumulative 6 million kilometer deviation from NASA's original path predictions, forcing 3 trajectory revisions in 1 week. The acceleration should have produced a massive debris cloud visible to any telescope. There isn't one.
NASA says it's outgassing, but there's no visible tail. They say they'll release more data after the shutdown. They responded to a celebrity tweet but won't brief the congressional committees that oversee their budget. And December 19th, 43 days from now, 3I Atlas will make its closest approach to Earth at 268 million kilometers. That's our best chance to observe it with every telescope we have. Maybe we'll see a debris cloud then. Maybe NASA will release those Mars photos and we'll all have a good laugh about how we got worked up over nothing. Or maybe we'll see more anomalies, more trajectory corrections, more coincidences that strain the definition of coincidence. I don't know what 3I Atlas is, but I know what the data says. And I know when people who should be answering questions are instead hiding behind bureaucracy. The rest of us, we're in the dark, by design. December 19th, mark your calendar.